Let's have this next problem. You want to identify 5 groups for your project proposal. Let's say it comprises of students. How many students are needed to ensure at least one group out of those 5 will have 7 members or 7 students in that group? This is, of course, obviously an example of a pigeonhole principle because you will have a target of number of members for at least one of your group, and you are trying to identify the number of students needed for that to happen. So your pigeonholes here, okay, the item or placement is actually your number of groups. Okay, so for example, again, going back to the pigeonhole principle, these are your holes, these are the placements where your pigeons will pass through. So what are a number of placements or possibilities for your pigeons to pass through? So you will have actually here 5 groups. That's what you want. Okay, next, for your pigeons specifically here, that will be your number of students because they are the students who will be assigned to your groups. Just like here, the pigeons will be passing through the pigeonholes. But we don't know yet what is that because that's the question. How many students are needed? Now, in the previous pigeonhole principle itself, we are actually just using n plus 1. Okay, but that happens when you are actually having a target. We'll have, say, let's see here, 2 members. We'll have 2 members, at least two members. Because in that case, you just need actually 6 students. Because if you're going to evenly distribute those 6 members, for in 5 groups, the first 5 students will be assigned to each of the group. The 6th member will guarantee that one of those group will have 2 members. Okay, that is the formula we use for pigeonhole principle, not the generalized one. But this time, we'll have 7 members. So you'll be using the formula for the generalized pigeonhole principle expressed as kn plus 1. So we already have our n. What we need is just k. Where do we look at our k? The k is actually identified by our intended target, but it's not 7 because in the definition for the generalized pigeonhole principle, it tells us that if n pigeonholes are occupied by kn plus 1 pigeons, and at least 1 pigeonhole will occupy k plus 1 or more pigeon. Again, k plus 1 or more pigeons. So the 7 there is k plus 1, not the k. You can now get the k as 7 minus 1. Your k is actually 6. This is what we need here for our k as we solve for the item. So if we're going to continue this is actually 6 times your n, which is 5 plus 1. So you will have here 30 plus 1. Then you will have here 31. You need 31 students to form 5 groups and guaranteeing that at least one of those group will have 7 members. Take note, 31 here is the minimum, not the maximum, because you will have at least one group. If you would like at least 2 groups, so you will have 32 in that case. So this is the correct answer. Of course, if you're not convinced with that, let's try to look into this. Say for example, as you distribute it manually, 1 to 5, let's say evenly, you're going to pick select students and place them in different groups and so on and so forth, not pick 5 into one group and so on and so forth. So the first 5 members, they are assigned to each of the groups, so each group will have 1 member alone. It's so far from 7. The second set of students, 5 to 10, let's say still evenly, you have 2 members now per group, so it's not yet 7. From 11 to 15, that's 3 members per group. 16 to 20, 4 members per group. Again, assuming evenly distributed. 21 to 25, that's 5 members per group. 26 to 30, this is where you will get 6 members per group. So that would mean the additional one will guarantee whoever, which group that student will belong, whether it's group 1, 2, 3, or 4, or 5, it will guarantee that one of those 5 groups will have 7 members. This is the minimum number. So 30 plus 1, that's 31. This is the further proof of this result. Okay, hopefully this is understood and is clear. We will have one more example that will be on the next video, so please stay tuned, and thank you very much for watching.